Hello, let's talk about something extremely important in pre-calc, and that is the unit circle. What you see here on the left side, this is a complete unit circle. But in terms of quote unquote learning about it and understanding it, okay, we're going to focus specifically on just the first quadrant. Okay, so what I've done is I've taken this quadrant right here and just kind of brought it over and drawn it freehand. You can see the wavy little curve here. And we're really just going to focus on that for right now. Okay, so first thing you need to understand about the unit circle is that its center is at the origin. So this point right here is on the coordinate plane 0, 0, which is why this point, which is over here, has a coordinates of 1, comma 0. It's 1 unit out to the side. That's the radius. Now, each one of these spokes, can I call them spokes? Spokes on a wheel, okay? Each one of these spokes is another radius, which has a length of 1. So this has a length of 1, 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 and this has a length of 1. So up here, we have coordinates 0, comma 1, okay? We're going to come back to these coordinates down the road here a little bit. First, going to look at how the circle is broken up. So you can see that there's specific angles here in the first quadrant, right? A 30-degree angle, 45-degree angle, and a 60-degree angle. And each one of those angles is tied into its radian measurement, its equivalent radian measurement, and the coordinates of a point. And the purpose of these videos is going to be to talk about, why these measurements are what they are. Okay, specifically the coordinates, but also some other concepts of symmetry involved, right? So really for this video, we're going to focus on the 30-degree angles, which are the pi over 6 radian measurements. Okay. Before we start though, this straight line, right, the positive x-axis is a 0-degree angle. It's also 0 radians. Okay. And then we swing up. This is a 30-degree angle right here. And if you convert 30 degrees into radians, okay, using our conversion factor here, right, the 30 and 180 can cross cancel in this case, and their bottom would be 6. So we get pi over 6. So that's why this is also a pi over 6 angle, right? Put a comma in between. But they draw they typically measure this on the line, okay? Because there's a whole lot of measurements going on here. So just understand that when we say this line is labeled as 30 degrees, what that really means is this angle that rotates up from standard position is 30 degrees. All right. Now, what we do to talk about these coordinates, and you can see the triangle that I've already drawn here in red. This point right here, okay, is a certain horizontal displacement away from the origin and a certain vertical displacement away from the origin, like so. Okay, and we can come up with those measurements if we drop this perpendicular right here. So we have this right triangle. Okay, here's what I'm going to do. I'm going to bring this guy down here just for a second and away from my ugly face. Okay, we just said that the radius of this circle is 1. So this has a length of 1, right? And we said that this is a 30-degree angle. And we said that we dropped a perpendicular. So that means this angle in this triangle is 60 degrees. So we have a special right triangle, a 30, 60, 90 triangle. And the side lengths of a 30, 60, 90 triangle are always in the same proportion, right? They're always in the same, or ratio, I should say. They're always in the same ratio, where whatever this side is, switch up this color just for a second, whatever this side is always twice as long as that, and this side is always whatever that is times radical 3. So if we look at this, if the length of this side is 1, and that's twice as big as this side, that would make this side 1/2, right? So there's the length of this side. Here's the length of the hypotenuse, this long side, the radius. And if x is 1/2, then this side length becomes radical 3 over 2. When I multiply radical 3 times 1/2, I just slide it into the top. So when you look at this side, the long leg of this 30, 60, 90 triangle, and it's radical 3 over 2, that was this horizontal displacement that we talked about up here. So that's the x coordinate of this point. So for this point, the x coordinate is radical 3 over 2. And the vertical displacement was this length, right, of this triangle. I know I keep sliding it back and forth. But the vertical displacement is 1/2. So the height of this triangle here is 1/2, which means the y coordinate is 1/2. Okay, so here's our 30-degree angle, which is equivalent to pi over 6 radians, that has coordinates radical 3 over 2 and 1/2. Now, before we move on, I just want to emphasize one thing about this. When you go around the unit circle, okay, we've talked about reference angles before. Any angle, any reference angle that's 30 degrees, like this one over here has a 30-degree reference angle. It's 150 degrees because it's 30 degrees short of 180. Look at its coordinates, okay? They are absolute value. They're exactly the same as these. The only difference is, I wonder if I'm able to zoom. No, I'm not able to zoom in. But the only difference is that there's a negative here. There's another angle down here, which is labeled as 210 degrees. Okay, its reference angle is 30 degrees as well, and its coordinates are the same. Okay, and over here, we have another angle with a 30-degree reference angle, and its coordinates are also radical 3 over 2. Now, the only difference is over here, keep in mind, this is the origin. So over here, the x coordinates that are on this side of the origin are going to be negative, right? So that's why this is negative radical 3 over 2 and positive 1/2. That's why this is negative radical 3 over 2 and negative 1/2, both negative in quadrant 3. And then in quadrant 4, the x coordinate is positive, but the y coordinate is negative. Okay, so that's where these numbers are coming from. We call this one of these bow ties. Okay, so if you look at a 30-degree angle and you take it down here on that diameter, the angle that's there has the same coordinates, same coordinates, same coordinates here. So that's our bow tie. Okay, I'm going to get rid of these because they kind of screw things up. So in terms of finding those coordinate measurements, anything that's on a reference angle with 30 degrees has those exact same coordinates. Okay, and think about that reference angle of 30 degrees to come up with these angle measurements. We should know this is 0. We should know this is 180. Okay, 30 degrees above 180 would be 150. 30 degrees below 180 would be 210. 30 degrees below 360 is 330. Because just keep in mind one last thing before we stop here. You know, the 330 degrees or the 150 degrees, it's really the angle from here all the way over to here, right? So the 150-degree angle is all of this, right? The 330-degree angle, which is down here, starts here, rotates all the way around to there, right? So we're in standard position, rotating positively. If you also notice, one last thing, the 30-degree angle that's pi over 6, where's the next pi over 6 angle? It's over here, where the reference angle was also 30 degrees, right? The other 30-degree reference angle had a radian measurement of 7 pi over 6, and this has a pi over 6 in it as well. These are the only 4 angles on this unit circle, on this bow tie, that have pi over 6 as their radian measurement. Okay, so there's some symmetry involved in this shape. And we're going to mimic that symmetry again when we look at the next 2 angles here. It'll go a little bit quicker in this next couple of videos, okay?